Okay, welcome back to the last project we're going to have in the Learn to Code course. And now we're going to get into a relatively complex project where we're going to utilize everything that we've learned in this entire course. And this project is going to build off of the intermediate project, but we have one difference. So what we're going to do is communicate with two Arduinos, except now we are going to be using a standardized communication protocol. And in the last video, we decided that to be the UART protocol. So the messages that we're going to send and receive, there's going to be some data in those messages. And each one of the Arduinos is going to interpret that data, and they're going to correlate it to some input-output function. And because we are using a serial communication protocol, we are now heavily diving into the serial commands. And this doesn't just relate to the serial monitor. So if we look at what we know or what we have used so far, we know we have this serial begin to begin communication. We can print something with this serial print line or serial print. We can read something using this serial read, but remember the little caveat that comes with this. And we had some small derivatives like serial read string until, so that's when we're looking for a certain character. But all of the things that we were using were for the serial monitor. Now the serial monitor is not going to help us for the communication between both devices, because for each of the Arduinos, we actually assign which set of TX and RX, or transmit and receive pins, that we're going to use. But these commands are still pretty valid. Instead of just having serial dot and then whatever we want, we include the number of the communication channel that we're using. But there's still a lot that we don't know. So if we look at that, we can have this command serial available, and that's going to return the number of bytes available for reading. So you could actually use this in the serial monitor. There's no reason why you can't. But we can also use this in the channels for the Arduinos. And while the number of bytes available for reading might not be too important, we can play a little trick here. So often you'll see this if serial available is greater than 0, and then something happening right here. And this is pretty much an if statement that checks if there are some number of bytes that are available to be read. So pretty much it says, if we got a message, do something. And usually if we got a message, you probably want to read that, so we follow that up by reading the values. So then we need to look at reading the message. And again, above we know that serial read, or that serial read string. We also have this serial read bytes. And the arguments inside of the parentheses here will be the buffer and then the length. And you can think of the buffer for this as an array that the bytes will be placed into. So you'll have to initially define an array, and then you populate that array using this read bytes right here. And in addition to reading the bytes, we can also write them. So for that, we can actually just use this serial write command here. And again, inside of these parentheses, you would populate those arguments with the buffer and the length. So now if we start to think about the project, because we are adding on to the last project, we can hold that open. And it's probably not necessary to increase the hardware complexity, so we can just have a few Arduinos and then some LEDs. So now if we think about the intermediate project, it's time to add some complexity. And in that project, what we had was the PC or serial monitor, and it's going to input some string as it's prompted for by the serial monitor, and it's going to send that data over to the host Arduino that's going to handle that input. So we had, when we got some message, it would trigger some pulsing function that would go to the partner Arduino, which would trigger some LED animation to occur. But also we would take that string and use this toInt command to turn it into an integer, and then we would call some function for which some computation would occur, and we would return some answer and then store it. And then returning to the partner Arduino, after the LED animation, another pulse function would be sent to the host Arduino. And then once this occurred and we had some answer, there would be some check for completion of the entire event, and then we would print out the output that we computed back to the serial monitor. Now for this complex project, really we're trying to get away from these trigger or pulsing functions. So we're going to have some modifications. And for the first modification, we're going to take the input of a number, and then we're going to store it. After we take that input of a number, we're going to take an input of a desired function, and whatever that is, we will also store that in some variable. So then with both of these things stored, we're going to generate some message. We're going to package those in certain bytes, and we're going to put that into an array. And then we're going to send that data from the host over to the partner, and that's going to be using UART. And the partner will receive that data and then deconstruct it and based off of the values that are deconstructed, it will execute the correct function that we sent to the host up here, and then we will store the result. So the result that we get, we're going to package that up inside of a message, and then we're going to send that over to the host, again, over UART. And then while the partner Arduino was doing all this, the host is also going to be running the exact same computation. And what the host is going to do, it's going to monitor for this result that the partner got, and it's going to receive that result and then compare that data to what it computed. And then if the comparisons match, it's going to turn on an LED. Otherwise, it's going to display some error message. And maybe you're asking, why are we having both of these devices do the exact same thing? We now have this redundancy that's going on, which most of the time you want to avoid that. But sometimes, or at least in real life, it's always good to have some redundancy checking, especially when you're dealing with things that involve safety or safety critical systems. You always kind of want to have this backup that you can refer to. And again, we're purposely adding complexity to display everything that we know. So if we think about how can we do this, again, we need to consider the host side and the partner. And on the host, we're simply just going to make an array and then send it as serial data. And we could structure that array something like the number that we enter and then the function that we enter. But these could just be representations packaged in some byte that we define, and then we just send that data over to the partner. In addition to this, we're going to run the separate calculation that we tell the partner to run. Then we monitor for that received message, and we have our conditions for the comparison. Partner side isn't too crazy. We just monitor for a received message, implement the proper function, store and send it over UART. There's no comparison on the partner side. So moving on to how we might want to do the workflow. And by now we know that we're not going to make the code for everything at once, both the partner and the host, and then debug the entire system. There's way too many moving pieces in this. If something goes wrong, you might spend an hour just to realize that you forgot some punctuation. Now, something that we're actually going to run into as an issue is sending this data. Because even at a relatively low baud rate, messages that we send are going to be way too fast for us to comprehend. And if you're going to be using Arduinos for serial communication, you probably need to invest into a logic analyzer. So if you're going to invest in one of these logic analyzers, then we can move on to structuring the workflow for each of the Arduinos. And the host is going to be doing a lot of work here, but ironically enough, it's easier to start with. And the reason it's easier to start with is because a lot of what we're doing is going to interact with the serial monitor, and we're pretty comfortable with the serial monitor at this point. We kind of just have to take some data, determine how we want to store that data inside of an array, and then send it over serial 1. And again, the host is using the 2560 Arduino. And then we can use the logic analyzer to verify that the data being sent is the data that we want to be sent. So if we can get the host to take some data from the serial monitor and then push it over the UART1 channel or the serial 1 channel, then we're in pretty good hands to work on the partner. And the partner is actually going to be a little bit harder because we need that message or that data to start. But if we get everything good on the host and we know that it can send data without any problem and it can send the correct data, we can start by having the partner at least check if it got some data and then read that data. So that's where we set up this if serial 1 available is greater than 0, which again is pretty much just going to say, hey, there's something available that we can read. We can then set up the code to at least read that data, and then we could use the serial monitor to display that data. So that would get us to a point where we can verify that what we enter into the serial monitor is getting interpreted by the host correctly and then sent over the UART channel. We can verify that it's correctly with the logic analyzer, and then we can use the partner to receive that data and then print it out on the serial monitor to make sure that the data is being transmitted successfully. And once we know that we are interpreting that data correctly, we can start to deconstruct that data and then utilize it as we need to. And then this is going to lead to us packaging up another array of data to send back to the host over that UART channel. So once we're pretty good with this part of the code, we actually go back to the host. But now this is pretty simple because we're just going to repeat exactly what was done for the partner. We just make sure that we are receiving the correct message, and then we interpret that message. But in this case, we're going to compare it and then do something with that comparison. So in the next video, we're actually going to look into this code, how we made it, and then we're going to look at a demonstration of the code working, which will then be verified from the hardware because we're going to turn an LED on to show that the comparison was correct between devices. If you learned anything new or useful, please like, comment, share, subscribe. Helps the YouTube algorithm, and we'll see you in the next video. Thank you for watching.